In today's lesson, we'll be learning about the tangent ratio. There is a mnemonic that helps us remember the main trigonometric ratios, and that mnemonic is SOHCAHTOA. If you don't know, a mnemonic is a saying which helps you remember something more easily. The T in TOA represents tan theta. Theta is this symbol. It looks like a zero with a line through it. And the O in TOA represents opposite, and the A in TOA represents adjacent. We'll learn about SO and KA in a different lesson. Let's start to unpack the meaning of these different terms. Take a look at the right. I have two right angle triangles. Let's focus on the one at the top. So I'm going to indicate that it's a right angle triangle with a square. Now, we know that the side opposite to the 90-degree angle is called the hypotenuse. So let's call it that. However, the terms opposite and adjacent are relative terms. They are relative to the angle which you are currently examining. So let's assume I'm talking about this angle. So I'm going to call that angle theta. Now, the side directly beside it is called the adjacent side, while the side opposite to it is called the opposite side. Let's repeat the same process for the triangle to the bottom. So I'm going to indicate that it's a right angle triangle with a square. That means the side opposite to that 90-degree angle is called the hypotenuse. Now, remember, the terms opposite and adjacent are relative terms. So if I'm currently talking about this angle, which I'm going to call theta, that means the side beside it is called the adjacent side, and the side opposite to that angle is called the opposite side. So as you can see, the terms opposite and adjacent are relative terms. So they will change positions depending on where your angle is. In our first example, we want to find the length of the unknown side to the nearest tenth. Now, we're only given one angle. We're given 58 degrees. So everything is going to be relative to 58 degrees. We know that this side is called the hypotenuse since it is opposite to the 90-degree angle. The side labeled 4.2 is the adjacent side since it is adjacent to the angle of 58 degrees. And the side labeled x is the opposite side since it is opposite to the angle of 58 degrees. To figure out the length of x, we need to use the tangent ratio, which is tan theta is equal to opposite over adjacent. So at this point, all you need to do is substitute in your values. The angle that we are looking at is 58 degrees, and everything else is relative to that angle. So opposite side would be called x, and the adjacent side would be 4.2. At this point, you need to isolate x. To isolate x, you need to multiply both sides by 4.2. I'm going to cut out a few steps. So I'm going to write that tan of 58 degrees has been multiplied by 4.2. Now, typically, when you're multiplying the tan of some sort of angle, you would write that number in front of the tan of that angle and not at the end. That way, you can sometimes avoid punching it into your calculator incorrectly. Now at this point, all you need to do is punch that into your calculator, and you do need a scientific calculator. And our side length of x should be equal to approximately 6.7 centimeters. Now if you took a look at the question, it wanted us to round it to the nearest tenth, which we have done so. So therefore, the length of x is 6.7 centimeters. In our second example, we want to find the measures of both acute angles in each triangle to the nearest degree. The very first step is to draw a diagram if it is not already provided. As you can see, there are two acute angles which have not been labeled. Let's first figure out angle BCA. I'm going to label it theta. Now, everything is going to be relative to this angle. This is going to be obviously called the hypotenuse since it is opposite to the 90-degree angle. This would be called the opposite side since it is opposite to the angle which we have chosen. And this would be the adjacent side since it is directly adjacent to the angle we are currently looking at. So we are going to need our tangent ratio. So tan theta is equal to opposite over adjacent. In our next step, all you want to do is substitute in your known values. We already know what the opposite side is, that is 11 millimeters, and we know the adjacent side is 8 millimeters. Remember, we're trying to figure out an angle, and that angle is represented by theta. However, how do we isolate theta? This is something that we haven't done before. Well, to get rid of the tan, you need to do the inverse of tan. So there is a button on your calculator which does that. So you want to do the tan inverse. So tan to the power of -1 of 11 over 8. If you want, you can change it to a decimal, or you can just keep it as a fraction. Now, for most calculators, you are going to have to press some sort of button to access the inverse of tan. You might need to press a second function button or a shift button, but it is not readily available unless you press a few buttons. Once you punch that into your calculator, that will give you the angle of theta. And since we want this to the nearest degree, as you can see was specified in the original question, I'm going to write this as 54 degrees. Now, it is important to remember that the inverse of tan is not dividing by tan. It is an inverse function. It is something that you will learn in a later grade, but it is not division. Now that you have the angle BCA, it is going to be quite easy to figure out the angle of BAC. I'm going to show you how to do that. Now, a lot of you will be able to do this in your head. I'm just going to show you all the work that goes into that. So we know that the interior angles of a triangle, when added up, should be equal to 180 degrees. At this point, all you need to do is substitute in your known values. We know that angle ABC is the right angle, so that's going to be 90 degrees. We are looking for angle BCA, and we just figured out the angle CAB previously, and that was approximately 54 degrees. Now at this point, all you need to do is isolate your angle BCA, and you can subtract 90 degrees as well as 54 degrees from both sides of the equation. I'm not going to write the work in for that. You should be able to do that on your own, and that should give you a value of 36 degrees for angle BCA. And there we have just determined the angles of these two unknown vertices.